All right, so we're going to look at solving systems a different way. Instead of graphically, today we're going to look at substitution. Next week we'll learn probably a final way anyway. Unless we do really well, then I might show you guys some more advanced math, which I think we'll have some time for this year. So we'll see. But we're going to do substitution and elimination. Those two in graphing are the main ways to solve systems when you're a young one still. Okay, so sometimes it's easier to do it one way versus another, so it's good to be flexible, okay? So both of these systems are ones that I would probably do by substitution if given the choice. Why? What does it mean to substitute? Well, it means to take one thing and put it in for something else. Exactly. But of course, if you're going to put one thing in for something else, those two things had better be like the same thing, right? So when I look at this first problem, there's two places, in fact there's even three places that tell me it's substitutable. The most prevalent, the most obvious place is right here. Because right here it says y is in fact also known as
1.
X plus 1, doesn't it? So if these two equations are going to be solved, these two lines are going to be solved simultaneously, that's what it means to be in a system, then you need to take what y is here and you can substitute it in for this y. Okay, so we're going to take the x plus 1 and substitute it in. So what do we have left then? Let's write what we have in the second equation. We'll have 4x plus the new version of y, and the new version of y was? X plus 1, and then that's supposed to be 6. Here, we only have how many variables?
2.
Just one. We just have x's. So if you have something like that, it's just like what we've been working with the other day when we reviewed solving linear equations. What do you do with the x's? Combine them. You get 5x plus 1 equals 6, and then you do what?
Subtract 1 from one side.
Yeah, you move stuff away from the x, right? So you go, this is 5x equals 5. And then does this 5 I divide, 5 divided by 5 on both sides gives me 1. Now, is that the answer?
No.
Well, yes and no. Because think about what we're trying to do here. Again, we've got two lines, right? We could do this graphically and graph the two lines. And the solution is where those lines cross. If they do, they might be parallel lines, like Ms. Collins said earlier. But if they cross, they're going to cross in a coordinate pair, aren't they?
Yes.
This is
So you
only
find the y.
half of it. We need to find the y. So how do you find the y?
Plug x in.
You could just plug the x in. That's it. And you can plug it into just this one or just this one?
Just the y, the top.
Either one. The top one's easiest. But either one should work because it's got to be the answer for both of them. Exactly. So if you put in the top one, that's going to be easier on this problem. So we'll go y is 1 plus 1. I'm taking this, taking my little arm and dropping it right there. So we get y is 2. How do you write your answer then? 1, 2. It's the point 1, 2. That's the solution to this system. If we were to graph these two lines, that's where they'd cross, unless we made a mistake. Okay, guys? So that's substitution. This problem's also substitutable. It takes maybe one more step, but it's still good to go for substitution. How do you know when you look at it that it's good to go for substitution? Where am I looking? Here? 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 There's lots of places I could be looking, right? But I'm looking right here. That's what tells me this will be easy to substitute. Because y is by itself. Almost. What's the only thing I need to do to get it totally by itself? Subtract 6x, exactly. So another version of this system, which, once again, it's up to you if you write this down again. But if you don't, and you get in that bad habit, in Algebra 2 next year, I promise you, you will have trouble. It's your choice. So I'm going to say subtract 6x on both sides here. So I'll get 11 minus 6x, like Lindsay brought up earlier. Does it matter which order I write these? No. The other one I don't have to do that with because now I have an identity for y. I know y is the stuff. So I can take this stuff and stick it in for that other y too. Because they're both the same y. They're simultaneously the same y. That's what it means to be a system of equations. So I'm going to say, all right, what do I have left? Well, I have 3x plus 2 of those y's. And it's supposed to be equal to -5. You guys got me? Okay. So let's do this one. Can you help me out? What should I do first?
Distribute.
Nice. We're going to go like this. And then combine which ones?
The x's.
The x's. What do you get, Richard?
You get -9.
Yep, 3 minus 12 is -9 of those x's. Then we got to subtract 22. I guess I'll show that one. It's going to be a whole lot of -27 in fact. Ooh, that came out nice. This is going to be a nice answer. Do you guys think that in reality you always get nice answers like the book gives us a lot of the time?
No.
I don't think so. So this gives me x equals negative over negative is
Positive.
positive. Don't expect your answers to always be positive because I think like if these are points, sometimes points are in the first quadrant. Sometimes they're in the second quadrant. Some of them, the x is negative over here. Down here, the x and y are negative. You know, things can be negative, okay? So am I done?
No. Y coordinate.
That's half. I need the y coordinate. How can I get it?
Plug it into
Plug it into one
one of the.
of these or one of these?
The top one.
Well,
The top one's the original one.
The one that's easier, but the top one would be easier.
Does it matter?
No.
That's
It doesn't. You can put it here and solve for y. You can put it here and solve for y. You can put it here, or you can put it in any version of those equations because they're all the same thing. All we did was modify this one here. It's still the same thing. It doesn't matter which one you put it in. I'm going to put it right here because that'll pop out y the fastest, but it's up to you. So I'm going to go in and drop 3 right there and say y is 11 minus 6 times 3, which is -7. So my answer to this problem is going to be 3, -7. And be careful because if you just get in the habit of like, okay, I do this process, don't think about things, and then I'm like, oh, okay, I put my first thing first and my second thing I found second, you're going to be wrong half the time because sometimes you'll get y first instead of getting x first. You know what I'm saying? That's going to happen. So read the coordinates. X, Y, X, Y.
What happens if there's a system of 3?
Yeah, a system of 3 equations
Yeah.
would be interesting to solve, right? There's all kinds of things that can happen. We're going to look at those next year.
Okay.
We might be able to look at a few this year. We'll see how much time we have, though. I'm not going to do it today, though, Richard, but great question, okay? Let's look at one application. All right, so we got 2 cable companies, thinking like Comcast and something else. We got to decide which one we'd like to pick. Similar to yesterday, a little bit of economics, right? Useful economics. So can you guys help me write the system down first, just like yesterday? So what's our system going to look like for these guys? Oh, and by the way, we should define our variables first, shouldn't we? So what is x and what is y?
Why is the total good? It's the total.
Total amount of money? So should we say costs? Dollars, okay. What's x going to be? I like it. Because it changes. I mean, you could drop your policy after different times. Now, if we were being realistic about cable policies, there'd also be all kinds of other things which would make this more complicated, like cancellation fees. If you cancel, cancellation fees usually depend on something, so there'd be another variable in there. And then we'd get into maybe a 3-dimensional type problem like Richard was talking about a second ago. So that's the reality. Well, let's keep it simple today. So what do you guys think? What are we going to have for the first company? She said y equals 60 plus 40x. 40 is the thing that's changing. Be careful about that. Yeah, I think that's per month. What's the key word there that should clue you in on problems like this? Per. And it's not always going to be the word per. That's the most common one. But there's other words that like describe something that's changing, like every. Very good. Things like that. Yeah, exactly. So that one's that. And the other one, how about 120 stays the same. That's fixed. 25 is changing depending on how long we decide to stay with the company. So if we weren't going to do this graphically like yesterday, this would be hard to do, especially by hand. Even with a calculator, you'd have to mess with your window a whole bunch, because why? There's large numbers, but which large number for like this first equation is going to be hardest to draw to like try to find the answer to this problem? Is it going to be the 60 or the 40? It's going to be the 40. Why, Ms. Newman?
Because it's going up.
It's going up 40. The slope says go up on this line 40 for every 1. That's going to be crazy steep. Crazy steep. It's going to be really hard to draw, right? Really hard to see. So that's why on this problem, I would never graph this problem if given the choice. I definitely do substitution, like we're doing today. So somebody tell me why this one's super easy to substitute. It's a little different than the other two. Ms. Collins?
It's saying what y equals.
Yeah, this one's saying what y equals, and also this one's saying what y equals. That means it's like doubly easy to use substitution on. Does that make sense? Because they both establish what y is. This one says y is that stuff. This one says y is that stuff. So I can take either one of these, the stuff 1 or stuff 2, and stick it in for the alternative y. And then solve it done. Okay? So definitely would like to do this one with substitution. I don't think that's a very hard algebra problem, is it? Just got to move your x's together like this. So we get 60 is 120 plus 20. Oh, that's gone. That's why I hate showing my work like this. Sorry. And then what do I need to do? Subtract the 60. I'm not going to show. 120 minus 60 is 60. And then I should divide by 15. So I get, oh, this came out easy again. God, even when I made it up, dang it. Shoot, I got a nice even number. In reality, that's pretty rare. So that's 4. Let's see. How do we get the whole solution though? Which one? It doesn't. So I'm going to plug it in the first one. Call it y1. 60 plus 40 times 4. 60 plus 16 times, that's 16, right? 160. So that's going to be what?
220.
220? Yeah. Okay. So I've got 4 and 220.
That's a weird graph.
Yeah. What's that mean though? Remember we talked about context? So let's explain what this means. What does it mean? I'm going to look for this. The cable plans are the same or cost the same, anything like that. The cable plans both, I could say, cost how much? $220 for 4 months. Now it depends what kind of question they asked us, right? They could have asked us, when do the plans cost the same? If they're asking when do they cost the same, you'd say 4 months is the answer. If they asked how much do they cost when they cost the same, you'd say $220. If they asked you to decide which plan is better for you based on different circumstances, you'd have to think about the graphs and the slopes and things like that. Like, let's see, what kinds of other questions could we ask? They asked on this one, if you plan to move in 6 months, which one is the plan for you? Which one is cheaper? If you plan to move in 6 months.
60. So it's like
Yeah, it'd be 120.
The second one or the first one? So let's think about this. Let's just draw a really rough sketch. This is a terrible sketch, by the way, right? This one starts at 60 and goes up by 40. So it starts at 60, really steep. That's obviously not nearly steep enough. This one starts at 120. It's supposed to be a 60, sorry. This one starts at 120. It's still really steep, but not quite as much. Now we calculated this crossing point. It's 220. So if you're going to move in 6 months, which one's going to cause you to pay the least? The red one. Exactly. Now if you're going to move in 2 months, which one's going to cause you to pay the least? The blue one. This could be all kinds of different circumstances. So yeah, when you like buy equipment like this, you've got to decide like what do I think I'm going to do. When you buy a gym membership, you've got to make the same decisions. Do I want to pay for 6 months? Do I want to pay for 2 years and get a cheaper rate? These are decisions you have to make. But it's all about like thinking about slope. Now when you do that every time, do you guys think when I do a gym membership, do I go ahead and write down a system of equations and stuff and make that decision? No, but it's built into like how I think about things, and that's the goal we should have too. Okay, so you guys said probably. Okay, I thought we'd look at one more example. My class thought that that was necessary. So here's a final example of substitution for today. What's different about this one is that it's also an easily substitutable system of equations, but in this case, we don't want to solve for y. We want to solve for something else. So you want to ask yourself, which thing is easiest to solve for? The x here is not by itself, so not so easy. The y here, again, same issue. Same issue here. Right here we have x already by itself, almost. We just need to subtract the 3y. So let's write down a version of the system that's more convenient to substitute. So if I subtract 3y on both sides here, I'll get x equals 12 minus 3y. Now I have x by itself, so I can do substitution. I can say x is this stuff over here, so I can take that stuff over there and substitute it in for the other x. Let's see what happens. 3 times 12 minus 3y minus 8y equals 24. There we go. I'm going to distribute, so I'll get 36 minus 9y. Those are like terms, put them together. Subtract 36 to the other side. And divide by negative 17. Negative over negative is, of course, a positive number. And you can see this time, since I kind of made this problem up randomly, it didn't work out as such a nice even integer answer. So I got 12/17. So remember, of course, that's only half of the point where these two lines cross. Since we got an answer here, they must cross somewhere. The y value, that's at 12/17, a little less than 1. We've got to take it and plug it in. I can plug it in here, 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 or here. Here it's easiest, so I'm going to stick it in for this one. So I'm going to get x equals 12 minus 3, take my 12/17, plop it in for y, and simplify. So that's going to be 3 times 12 is 36/17. If we do what we looked at with review the other day, common denominator of these is going to be 17ths. So I'll make this be 17ths. Might need my calculator real quick. Let's see, 12 times 17. I got 204 over 17. Now it's got a common denominator, 204 minus 36. It's 168/17. So these two lines cross in not so easy a place. If we graphed it in our calculator, we'd probably get decimals for this spot where they cross. But that's the answer, okay? One of my students also asked, are there any problems that you can't use substitution for? And the answer to that is no. I mean, all regular systems can be substituted. It's just a question of how easy or difficult that process is going to be. If, for instance, I'd done one little thing to this problem, it would become much more difficult to substitute. If instead of just x here, if I'd had something like 11, now it's going to be hard to get any of those variables by themselves. So in that case, you're going to want to try a different technique, or substitution is going to lead to many, many fractions. But that's up to you. See you next time.